Right, so sent 2 of these chargers to take a look at. One of them we're going to take apart. One of them we'll stress test, and yeah, so I will not give this company any rights to edit the video. They're seeing it when you're seeing it. Similar to Michael Fisher, if you're looking at his videos. So I was actually looking towards getting one of these GAN chargers myself, but never really had an absolute need for compactness, so never went for it. Let's first of all take a look at the device itself. So it is reasonably well built, right? Quite sturdy. Has this LED that blinks when it's outputting and static when it's not, and the US pins, right? Can't seem to really take it apart, so that's fine. Okay, so let's have a look at the output ranges this thing has. Okay, so in terms of output ranges, we obviously have the 5, 9, doesn't have 12, does have 15 and 20, right? And so later on in the video, we're going to draw 30 watts from it for an extended period of time. I'm going to do a time lapse, and we'll see how this copes, how hot it gets, and probably even before that, we'll take a look at a teardown, see what they have inside, as well as some images of the scope, check the noise and operating frequency that this runs at. All right. All right, so for the stress test, here's our setup. We have a thermocouple glued to the top side. What else do we have? We have a power monitor just to see what kind of draw we're pulling out of the charger. And then we have a power delivery trigger. So this is basically constantly telling the charger to yes, keep giving 20 volts. And this is going via these cables into my oil load. Hopefully you can see how that fills up. I've left a bit of air here, and since this is simply a wire resistor, and it's also not very precise, which is why I'm also paralleling a programmable load, and this is going to bring us to exactly 30 or above 30 watts, right? So we can load it fully. Okay. Here we have the time. This is not super accurate, but for the purposes of this video, we only need a relative figure, so that's fine. Relative humidity, no one gives a shit, but that ambient temperature should help. All right, so next up we'll be looking at what kind of noise there is on the output of this. For this, we're going to be using a passive load just to make sure nothing oscillates and impacts the charger's output. Get as stable of a reading as possible. As we have the same setup, trigger, monitor, and passive load. All right, and to this we'll actually be tying the oscilloscope probe. Most of the tests will be done on 5 volts because I have some other chargers that I want to benchmark this against, and these are mainly 5 volts with the exception of this. And we'll also be having a look at a pretty good power bank in my opinion, and we'll see how that compares as well. All right, so first off, let's just start with a suite of 5 volt tests, and we're just going to do 1 amp and 2 amps because, yeah, should be good enough. And let's first take a look at absolutely no load. And in this case, we're getting around about 200 millivolts. It does fluctuate up and down, but that's kind of where it's at. Let's take a quick look at the frequency. And in this case, we have somewhere around 1 kilohertz. All right, and let's start loading it down. Go for 1 amp. 1 amp, we're getting slightly slightly larger noise content. If we were to stop this and actually zoom into it, we can see that the frequency has gone up. Let's see just by how much. So let's just take two of these peaks, and we're at 22 kilohertz. All right, so the frequency is a lot higher now, and let's go for 2 amps. All right, so 2.2 amps is the closest I can get with this passive load, and in this case, we're approaching 300 millivolts peak to peak. All right, so 36 kilohertz. So and the frequency has gone up as expected. Okay, so next up we'll be testing the Bazius. Right, this is also a 30-watt charger, as you can see, quite a bit bigger, and we'll also test the Type-C output because why not. All right. So first of all, let's just go for no load. No load 170. Okay. 1 amp. 1 amp is 160. This actually has pretty bad caps inside of it. And let's go for 2 amps. And 2 amps is slightly better. Let's see the frequency we're at. 120 kilohertz. Let's just go with a known reference. So this, as far as I know, is the best charger I have in terms of low noise. So let's test it at 5 volts. Why won't this go in? All right. So at 5 volts, this is barely registering. We're seeing around 50, let's say, millivolts. Okay. Go over to 1 amp. 120. Go over to 2.2 amps. 100. 130. So again, this is a very low noise solution. DN aux only goes up to 12 volts, not super powerful. All right, the aux charger seems to have some spikes in there. All right, so peak to peak is quite high open circuit, so 350 millivolts. This is actually quite bad, but again, it shouldn't really kill anything. Let's go for 1 amp. 1 amp is 400, half a volt peak to peak, man, that is. Okay, and 2.2 amps. 2.2 amps, pretty similar story. This, we could load even more and it doesn't really. So yeah, this is kind of noisy. Original 5-watt Apple charger. So let's see how this handles stuff. Open circuit, super nice, 80 millivolts. Okay, let's go higher, 1 amp. I mean, technically, this is the highest this can go. And we're seeing 100 millivolts. This is quite quiet as well. Not quite as quiet as this one, but quite quiet indeed. And last but not least, let's also check a power bank. And again, open circuit, 150, quite okay. 150, it's not even seeing the 1 amp. 2.2 amps, 200 millivolts, again, super quiet. And this we can load quite a bit higher. 3 amps, we're seeing 200 millivolts. And if we max it out, we only see, again, 200 millivolts. So yeah, this does work pretty well, I have to say. All right, so that about settles this test. And next up, we'll probably go over the teardown. All right, so now moving on to the teardown. I see there's a seam over here, and I'm expecting the rest to be all one piece. So let's see, how will we get in? So whenever cutting through plastics with a Dremel, I highly advise using one of these diamond bits, diamond disc. Alright, so pretty nice construction on the back end. I do enjoy this style of charger, so let's see if we can pop it out. If not, we might have to hoik it out. Alright. So, yeah, it does actually look quite nice. Wow, I think they have cooling on this capacitor. Or what is this? I think they might. Alright. Yeah, no, this actually does look like quite a modern design. Pretty fancy packages. Question is, do we go further? A lot of packing, right? This also seems to be some kind of, quite interesting. Haven't seen this before. Alright, this kind of, how charged is this though? Not at all, okay. It has a fuse built in, ACN. Really would like to pull the data sheet from this because it does look very nice. Alright, so this seems to be one of those power supply chips that includes both the high side and the low side, and they have an optocoupler inside, right? And so this is what they're doing. And the external MOSFET, I don't know what that's for. It's probably for disconnecting the output. I'm not sure, but yeah, this is a GaN device, right? So that's definitely the case, and the efficiencies seem to be quite up there, right? So this chip can support up to 100 watts if you cool it adequately, so that is kind of nice. Not super familiar with the branding. Actually, they do have quite a bit of separation. Is this the MOSFET? This is the MOSFET. Alright, so we're going to pull the data sheet for that. Put it on the right side. This must be the power delivery controller. This does all the protocol negotiation for the different voltages, power ratings, all that kind of stuff. Okay. This looks like heat conducting, whatever this is. Transformer stuck in the middle. Right, capacitors are 105 degree rated. So this is quite okay. Don't know the branding, but yeah. Nothing super fancy, nothing super crap either. Yeah, I think we do a full teardown of this. And even unwind the transformer. Capacitors all look quite okay, and some have these bugs over them. Like, if anyone knows why, would be very curious to know. Like, why do they have condoms on their capacitors? I mean, sure, safety is important, but I mean, yeah. Okay, so I'll bring the desoldering tool in frame, and we'll go for it. Right, so now that we've applied some more solder, should be easier to suck. So let's see. they have added quite a lot of supports, which is quite cute, to be honest. I'm really liking this design so far. Okay, so I suppose this has so much of this heat conducting paste, it would have been wise to not etch this and have this all be copper, perhaps even vias, and radiate some of the heat in the front, right? So like in this area, but they haven't done it. I mean, it's still pretty good, but not perfect, I suppose. Okay, so let's elaborate this side as well. All right, so we're getting pretty far along. We have another one of these capacitor condoms. Really have no idea what these are for. Like, if anyone has an explanation for this, I would be extremely curious to know. As far as this potting compound, extremely soft, right? So it's, I would suppose, 50-50 between heat compound, right? What is it called? Like what is it called? The thing you put under heat sinks. So it is very soft, but it is still coagulated enough to stick to stuff, right? So kind of potting compound / heat spreader compound. Very interesting. I have not seen this until now. We can remove it. Right, so it's taking a lot of the heat away from the main transformer, which actually occupies a fair size, right? A fair chunk of space, fair chunk of volume. These would be the secondary. Do we have a diode though? I would expect a diode. So this is both the main input and the secondary side. So our TA and TB supposed to be secondary windings. Right, so if those are secondary windings, they get rectified by this diode. Okay. So they get rectified by the diode. And then this is the Type-C chip. Again, I haven't seen any of the data sheets. We'll have to pull those up during the video. So I'm just guessing right now. So this would be the chip that does all the comms, or this is the chip that does all the comms. What the hell is this? I have no idea. Maybe this is the diode. Or what is this? I don't know. Anyway, and this would be the main output capacitor, 25 volts. Very sexy package. I don't know. I mean, this is very nice. Okay, so basically the entire adapter can be split into 4 main components. And so let's start with this one, which is perhaps, right, let's just go from mains to low side, right, high to low side. So we have the mains input coming in here, right, through these pressure contacts. Goes and gets rectified and immediately gets sent off right? It does get go through a fuse and a tiny common mode choke. Is this a common mode choke? Yeah. Fuse, common mode choke, rectified, and then goes off to this board. This board then feeds it into this main controller IC, and this is what pulses the transformer. This also has the main decoupling capacitors, 400 volt, 105 degree rated. I'm not recognizing any brands, Tiepo, I don't know this brand, but they look, I don't know, they look okay. You can't really judge a capacitor based on the plastic outside, but at least the plastic outside is okay. Not name brand. What else? So it gets, right, the rectified mains comes in here, gets smoothed. We'll take a look at the power rating. I'll put the power factor on this, but it's probably not super great. Shouldn't really affect regular users, but anyway, there seems to be no power factor correction. Or then this big ass chip pulses the transformer and controls, right? This also has a built-in microcontroller and also controls the LED, which is on this board, which seems to be a 3-color LED. Haven't seen it blink anything but yellow, but maybe it has debug modes and also blinks different colors. Alright, so where were we? This board gets mains in, smoothing caps, controls the LEDs on this board, and pulses the transformer, which is this. Then the transformer goes to the secondary board, which is also the input board. It goes on this side. This would stick on here. So anyway, let's tear down the transformer and then we're kind of done. And here we go, a small ferrite bead. And these are the extremely thickly coated secondary windings. Yeah, this is thick ass coating. All right. So this is basically the entire secondary winding. I'll let you guys count how many windings there were, how many turns. And then here we should have the primary and and the feedback winding. Yeah, pretty sexy construction, I have to say. All right, so so there is the output winding. This is for sure the output winding with the thick insulation. So this is a very safe transformer, right? All things considered, a very sexy piece of kit. We have a thin winding and then 2 thicker windings. I really don't know what these are for. Maybe the chip derives an auxiliary power supply from one of these, which is constant, doesn't vary. I don't know. I really don't know. I'll check the data sheet and we'll correlate this. And if there is anything else to be said, I'll go over this. But all in all, this is a where is it? It's a very serious piece of kit. I actually did not expect this to be this well made. But yeah, I don't know. Like This is not a joke. This is definitely not a joke. All right, so that's been it. If you guys have any questions or suggestions or commentaries or comments or whatever, leave them down in the comments. Criticism is welcome. I know I talk a lot, but I honestly do enjoy these kinds of reviews where the reviewer does go way in depth and does a lot of side talks based on what is happening or on what is not happening. Anyway, that's it for now. Gonna go to bed. Have a good one, guys.